Welcome to the screencast for 7.2. So 7.2 is about solving exponential equations. We're not doing the inequalities, we're just doing exponential equations. So if I asked you to solve 3 to the x equals 9, what does x equal?
2.
Surprise!
Participation.
You can do it. Every time people participate, then ask me if they're going to get a point for it. Even if I was going to give them a point, the fact that they asked, I don't anymore.
And how do they know if they're getting a point or not?
They see it on the weekly participation grade. Right, so here's the goal, right? Like participate, don't sleep, don't be on your phone. Like,
You mark me down for sleeping?
yes, I mark you down when you sleep. Are you kidding me?
Go quiet.
These screencasts are just going to be quiet.
Well, at least people watching them will know. Here are the rules. They'll know. All right.
It's in the syllabus.
It is. It is in the syllabus. All right. So if I wrote it like this, it'd be super easy. So I'm starting off with an example that you already know of because you know what the answer should be. What if I wanted to solve it a different way? Can I rewrite 9 in terms of 3 to some power? Yeah. What is 9? 3 to the what power? 3 squared. Okay, so I have 3 to the x is equal to 3 squared. Okay, since there's this little thing called an equal sign in between them, and I have the same base on both sides, that means the exponents have to be the same as well. You follow?
Yeah.
All right, so if they have the same base, and it's actually equal, guess what? Then they have to be to the same power, meaning I can set the exponents equal to each other. X equals 2. Okay. So that's okay, because we already knew the answer, what it should be. But if I gave you a different problem like this, like what?
Oh, you just set it as x plus 1 equals 4, right?
Well, not quite. It has to be the same base.
Oh.
Yeah, I'm moving ahead. Okay, so can I okay, you're good. Can I rewrite 16 in terms of 2 to some power?
2 to the power of 4.
Yeah, 2 to the power of 4. So I have 2 to the x plus 1 power equals 16 to the 4th power to the 4th power. Wait, if I have a power to a power, an exponent to an exponent.
You add. Multiply.
Yep.
16.
We're going to be going through literally, this chapter 7 is working on the last 2 chapters that we did heavily. This is rules of exponents. So if I have an exponent to an exponent, you're going to multiply them. So 2 to the x plus 1 is equal to the base 2 to the 16, because 4 times 4 is 16. All right, can you guys see that still? No? Okay. Nah. Okay, so wait, now I have the same base. Before, one was a one was a base 2, the other was 16. Now they both are base 2. So if the bases are the same, that means the exponents have to be the same. Yes, Miles?
Now you can do x plus 1 equals 16 because the bases are now the same.
Exactly. How do I further solve it? How do I get x by itself?
Minus 1.
15.
That's 15. Good. So we can do this. This is like the basic part of the first half of the lesson. This is what we're doing. To solve an exponential functions, write the powers on both sides of the equation in terms of the same base. And remember, a negative exponent is useful when you're converting a number to its reciprocal. So we'll hit the negative number part a little later, but let's try this. Let's try this one using the same rules we just did. 3 to the x equals 9 to the 4th. So question is, which one do I want to convert to? Do I want both bases to be 9 or both bases to be 3? Which one can I write in terms of the other?
3.
I want to change 9 into 3 to a power. So I have 3 to the x, and I want to rewrite 9.
So it's going to be 3 squared and then 4.
Exactly. So wait, how do I actually combine when I have a power to a power?
Multiply.
What are you doing? Okay. As long as, if you don't like bother people, whatever. Okay. I have 3 to the x is equal to, is it 6 or 8?
8.
8, because we multiply 2 and 4. When you have a exponent and then that to an exponent, you have to multiply. This is what I'm talking about, an exponent to an exponent right there. You have to multiply them. Okay, so since I have the same base, I see x is equal to 8. I set the exponents equal to each other. Okay, let's do part B. Do we need more time to write this down?
Yes. Okay.
Okay, let's go on to B. So this one's a little harder. Which one do I want to like which one can I rewrite in terms of the other? Miles. Shh, Miles. We're not 9 anymore.
I'm in the fourth.
Miles. Okay.
You turn the forward into 2 squared. And then parentheses 2x minus 1. Then you multiply the outside with the inside of the parentheses at the square root. So it'll be 4x minus 2. And then you, the bases are the same, so then it'll just be 5x. Equals 4x minus 2. You subtract 4x. So then it's x equals negative 2.
Exactly. That was good. See, and that is where the participation point. Like leading through 2 different examples, being on task, that's awesome.
Can you call them Miles? Well, I tried to do it. And
Because you already led us through a problem.
what?
You already led us through a problem, and then you asked if it would be a participation point.
Well, because I don't know if you get participation for just going on the board.
If it's not just like answering a single question, it's like going like, you know, actually like really not just like being here, answering a simple question, but like leading us through a problem. Like not just being like, oh, the answer is 5, but like why? Right? So when he got to the bottom, he's like, oh, and the bases are the same. So then, because they're the same, I can set the exponents equal. Like it's like the next step. All right, so we're gonna do D, and then we'll take a little aside because C is a little harder. So we're gonna do question D.
I do it.
Lily. I'm giving everyone a shot.
I haven't.
Okay, let's just think like, I'll call on you later, okay? All right, Lily.
So instead of 81, write 9 squared equals 9 3x plus 2, and then equal, yeah, and then you subtract the 2 for the x to be alone, and then you divide the 3. Then, is that?
Yeah. So one thing you might want to do, if you're like, well, wait, is this crazy? Like, part B, how'd we get a negative number? Part D, how'd we get 0? So one thing you can do is plug in and check your answer. So you can check your answer. So if I plug 0 in for x, let's see, is 81 equal to 9 to the 3 times 0 plus 2? So 81 equals 9 to the 0 plus 2. So I'm showing all of the steps. Wait.
Oh, it is.
Okay, so that works out. So that's fine. And I can double check number B, because that's weird, right? B was a negative 2. Like, is that right? Like, I don't know. Let's see. So number 2, I'm going to plug in and check.
Oh, so this is when negative and 0 is more.
What? Ignore the, like, brown. That's... What? What's wrong? The brown stuff? Don't worry about it. We haven't done it yet. Okay, okay, whatever. I'm moving up. Okay.
Well, hold on. I'm actually paying attention. Don't put me in the same situation as them, folks.
No.
X equals 0, and we can plug it in.
Can you
Yep.
keep me here on the seating chart, please? I like that.
As long as you have your feet on the table.
When he becomes a CEO, the first thing he's going to do is buy the desk so he can put.
It's like, I want to see you actively engaged, like writing the notes, following along,
Like, even after
not
nice dinners, I
sleeping.
sit like this,
Yeah?
Just, I can't keep my feet down. It's like that.
So you put your feet on the table at
Like
home?
when I go to like a nice dinner.
You put your
it's
feet
like I
on the
keep
table
my-
at nice dinners?
No,
Okay.
but I keep it underneath like this, like with one leg up.
Okay, cool. That's enough time for you guys to write that down. Let's go check it. So I'm going to plug in -2 for x. Let's double check this is right. 2 to the 5 times -2 should equal 4 to the 2 times -2 minus 1.
Wait, are we just skipping C altogether?
No, I'm going back to B and double checking. Plugging in, because having a negative as an exponent, that's weird, right? But we can do it. So this is 2 to -10, and it should equal 4 to the, let's see, 2 times -2 is -4. -4 minus 1 is -5. I wouldn't drink that if I were you. I don't know, I was just making sure you weren't. I don't want you to die, like, okay.
She's being nice to you or laughing at her face.
No, it's just funny because, like, who would drink it?
Somebody.
Hey, I was in this room for like 2 years, and yeah, people. So.
Or she came off a farm.
Well, I would too if we lost the bathroom pass for someone.
Why do you say that? Because she's wearing plaid, so farmers wear plaid.
Yeah.
Yeah,
Why?
You're from the corn state.
It's funny because it's not true.
Farmers?
And I'm just like trying not to beef with Yarden right now, so.
Yeah, you're wearing plaid right now. Farmer
Confirmed. She's the one that grades you and you're calling her a farmer.
Are you done?
I didn't call her a
Are you
farmer.
finished? Are you done?
Okay, let's focus.
You're done?
So, 2 people that have their calculator out. So make sure your phones are totally put away, not on your desk, not on your pocket, whatever. Like totally put away in your bag. Totally put away. All right. Yeah, I know. This is what I'm talking about when I'm like, I see it.
I swear I'm not texting them.
See, this is discrimination. I don't like that.
What do you think she grabbed the water for? She's wiping this thing off. I see it. Okay, so does someone have their calculator out?
You want me to take it out?
Calculator, not phone. I want calculator. There's a charger. If you want to charge your phone, take it to room 127.
127.
Yep, it's... All right, ready, Miles? I want you to plug in 2 to the -10 power. What is that?
2. And then.
-10 power.
How do you do the negative?
Never mind. All right, 4 to -5 power. Your calculator will tell you this is it as well. Guess what? They're the same thing. Joy, joy, it works. Okay. Okay, let's keep going. If you caret key, there's a negative. There's a minus key. Yeah. What is going on right now? What is this? Okay, let's keep going. Let's keep going. Okay.
No, these are
Let's sort of move this over.
They gave us. Oh no, we did.
Cool, cool. Okay, so I'm gonna do a couple other like side problems. So the first thing I want to do, and this will help us for part C. First thing I want to do, and this will help us for part C. I'll wait. I'll wait.
Please be.
Yes. So before we do part C, because we did A, B, and D, I'm going to do a side problem. Why? I'm doing a side problem before I do part C. Because this will help us out.
If you do 3, it turns into 1, and then you should multiply it to the.
Hold on. So I have 1/3 to the x, and I say that's equal to the 9. I mean, equal to 9 to the 2x power. So can I rewrite both sides
Yes.
in terms of something? What should I rewrite that as?
Put 3 on both sides.
Put 3. Okay. How do I rewrite? How do I write 1/3 as 3 to some power? But 1/3 is not equal to 3. How do I make it be the same? Huh?
Reciprocal.
It's a reciprocal. Okay, so 3 to the
1/3.
-1 power.
Yeah.
What's 3 to the -1 power?
1/3.
Well, 3 to the -1. How do I get rid of a negative in the exponent?
By making it on top.
By flipping on the other side of the fraction. So 1 over 3 to the 1st,
Yo.
which is 1/3.
So we went from 1/3.
So 1/3.
Yep, so it's the same thing. So 3 to the -1 is the same thing as 1/3. 3 to the -1. And then can I rewrite 9 in terms of 3?
Yes.
Yeah, 3 squared.
2x.
Okay, so let's set these equal. So I have 3 to the negative x is equal to 3 to the 4x. Now that I have the same base on both sides, what am I going to do?
Negative x equals 4x. You divide by.
You add in that.
I can just add x on both sides.
0 equals 5x.
0 equals 5x. How do I get x by itself?
You divide by 5.
Divide by 5.
So then 5 equals
0 equals x. So if I plug back in, what's 1/3 to the 0?
1/3.
1/3 to the 0 power? 1. What's 9 to the 0 power? 1. What's 50 million to the 0 power? 1. Anything to the 0 power is 1. Okay.
What about quintillion?
1.
Okay. Let's do another one. Yeah, let's do another one.
Try to do C.
Actually, we're gonna do C together. But first, before we do C, I made a little chart. Let's do C first, and we'll do the chart.
Try to do C.
So I have 1/2. Sure, walk us through. Let's make sure everyone's paying attention first. I'll wait.
I'll wait as well. So we have 1/2, and we want to make it into a whole number. So we do 2 - 1 to the power of -1, because as we demonstrated before, it's 1/2.
Oh, this is supposed to be an 8. I'm sorry.
Okay, so that's an 8. So 8 2x plus 1, but we can turn it into 2 if we put 3 there.
2 to the 3rd power.
And then you multiply that. So it's 4x plus 1, negative 4x plus 1, I'm so sorry, equals 2 6x plus 3. And then you do negative 4x minus 1 equals 6x plus 3. And you add 4x on both sides to get rid of it. And then you subtract 3 to get rid of it. And then you have negative 4 equals 10x, and then you divide it. So when you divide it, you get negative 4 tenths equals x. So your x is negative 4 over 10.
Which is also negative 2/5.
It's also negative 2/5.
Good. So this is a harder one because there's a fraction. Just so you know, like whenever I do screencasts at home, my cat meows in my bathroom, like I can hear it on the screencast. So like I go back and I edit it out.
Like, yeah, I was like, God damn it.
Right, or like if my neighbors are like fighting, I go back and I like re-record the part where they were fighting. That way it's like that, because I try to make it succinct, but I'm like done making it short. Whatever, they can, whoever watched the screencast can listen to the whole ordeal.
Wait, hold up, I have a question.
Especially when you say stuff. Yeah, this picks it up. This mic picks it up.
Really?
Yep.
That's true. You record in the bathroom?
No.
Her cat is in the bathroom.
And the meows can go through, it picks it up?
There's like an echo to the meow.
Okay, hold
What's your cat's name?
up, stop. We're doing a test. I'm gonna wish you something, and then we'll see if the mic picks it up.
I'm so sorry.
No, muzzle. You need a muzzle. What's your cat's name?
We're gonna keep going with the lesson.
I'm actually interested in
What?
Have you heard of David Bowie's Space Odyssey?
Yes.
No.
I actually have. My
Wait, is
dad
that
made
how
me
you
watch
say
it.
It's not Bowie.
Oh my god.
It is Bowie.
It's original.
I'll just say it different, whatever. Major Tom's the name. It's like the astronaut.
Wait, so
Major Tom's my cat. Okay, let's keep
Is it
going.
white?
I have a dog. I wanted to name it Mowgli.
Okay,
Like in the jungle book.
yeah.
I couldn't say it. He was like,
Mogul.
Sucks. All right. Let's keep going.
"I keep English."
He's cute. Let's keep going. Let's keep going.
Are we gonna check?
Imagine if we have time at the end of class, you can do your homework. Okay. So let's fill us in. What's 2 to the 1st power?
3 rounds.
2 squared.
4.
2 cubed. 2 to negative 1.
Oh,
One half.
shoot. You caught me surprised.
Wait, do I need this? I need this. I need to write this down.
What?
I need to write this down.
That's a thing for you to decide yourself.
No, like, it's
This is helpful. I'm trying to help you guys understand negative exponents again.
just putting down my phone.
Better.
I'm ready.
You realize I'm gonna upload the solutions to the notes, and I already asked you to put away your phone. Okay.
No, I know,
Yup. Like literally in your bag, not even on your desk. Like totally put away. You can clean it later. I don't even want to see it. Cool. Put it away then.
I don't want to go back and copy this on someone else and try it.
Yup. Do it. 2 to the negative 2. That's literally 1 over 2 squared, which is 1 over 4. 2 to negative 3. That's 1 over 2 to the third, which is 1 over 8. Okay, if I do 1/2, what's 1/2 to the first power? 1/2. 1/2 squared. There's 1/2 times 1/2. Well, that's 1/4. 1/2 cubed.
20.
What's 1/2 to the negative 1?
Negative 1. Gotta be.
2 over 1, which is 2. 1/2 to negative 2.
4.
2 squared over 1, which is 4. And then this one's 8.
No.
So that's just a little like helpful review. Trying. Okay. Trying. No. No. Okay. All right, let's keep. Well, do you guys need a little more time? Okay.
Man.
Just don't talk. Just like everyone, just don't talk and just like write it down. If someone talks again, I'm just gonna move on. So, are you coloring? Okay. Did you write this down? Are you paying attention?
No, I'm paying attention. It's just when everyone's talking, I just start, draw. Would you rather have me like add another loud voice? No, right? So I'm trying to be quiet.
Okay, we're going on to the next thing.
And I can't go on my phone, so this is another thing to keep me
Okay.
busy.
Writing exponential functions.
I never do this stuff around.
Writing exponential functions. Recall, exponential functions have the form y equals a times b to the x power. This is what we worked on the last 2 lessons. So when you're solving problems that model real life, you should write an exponential function or a function that's unique to the problem. So here is y equals a times b to the x power. Y is going to be your final amount. A is going to be your original amount, how much you start with. Y is how much you end with, your final amount. And b is the constant. It describes how the quantity changes. Is it doubling every time? Is it tripling? Is it quadrupling? Are you going to constantly be multiplying by 2 every time? Like, what's your base? All right. So how do you actually write in exponential functions? You substitute the given information into your general form. Y equals a times b to the x. So if they give you the final amount and the initial amount, go ahead and put those in there. So first you're going to solve for b, substitute it into the main equation, and leave x and y as variables. That's how you write an exponential function. Solve what the constant would be, and then you can leave it with x and y variables, and then you can plug in for a certain number. Okay, so I'll leave this up here, but we're going to do example 3. Christian, what? How the quantity changes. Yep. All right, so Kristen starts an experiment with 7,500 bacteria cells. After 4 hours, there are 23,000 cells. Write an exponential function that can be used to model the number of bacteria after X hours if the number of bacteria changes at the same rate.
What's
Slow-
Kristen doing on her free time?
Yep, I needed that feedback. Cool. So we start with 7,500 bacteria cells. So this is how much I start with. So this is going to be my A, my original amount. There are 23,000 cells after 4 hours. 23,000 is my final amount, my Y. If you look at part A, which is below, it says write an exponential function that could be used to model the number of bacteria after X hours. X is standing for the number of hours. Here we have 4 hours, so that's what I'm going to plug in for X. At first, this will allow me to solve for my constant B. Mouse, please turn around. Once we solve for B, I can like make a general exponential function, then I could plug in other numbers to find other values of bacteria. All right, so part A, we're writing an exponential function. That's our goal, is to write an exponential function. My A value is going to be 7,500. That's how much I start with. My Y is 23,000 because that's how much I end with. And then my X is 4 because here X is the number of hours. The general form is Y equals A times B to the X power. So if I plug in my values for all 4 of those letters, I have 23,000 is equal to 7,500 times B to the 4. Now the question is, just like last chapter, how do I solve for B? How do I get B by itself? Do I subtract? Right now 7,500 is being multiplied by B to the 4th. I'm divide it. So I'm going to divide 7,500 on both sides. Okay. So then I'm going to have 3.0667 equals B to the 4th power. So think to yourself, how would you get rid of this 4th power? I could do the 4th root on both sides.
Or you can
Another,
the exponent of the 4th.
or I could put both sides to the 1/4 exponent. By having it to the 1/4 exponent, the 4 and the 4th cancel out on the right side.
Yeah.
And on my left side, the 4th root of 3.0667 is going to be 1.3233.
How do you do that?
Well, reason 1, I already taught G period this lesson. Reason 2, I go through the notes before I teach you guys. Because I try to predict questions you guys will have.
That's interesting.
Yeah, me trying to be a good teacher. Yep, interesting. All right. No sucking up, not needed. All right, so I have Y is equal to A times B to the X power. This X power only is hooked on to the B power. Is only hooked to the B base. Right? That's how I was allowed to divide by that A. So what I'm really trying to do is write an exponential function. I have my B value now, and it said leave X and Y. It said leave X and Y as variables right here. It said leave X and Y as variables. So I'm going to leave X and Y alone. I have Y is equal to A, which was 7,500, times B. I found my B value, 1.3233 to the X power. Now I have this exponential equation. I can come down to part B, where it's wanting the number of cells after 12 hours. How do I find the number of cells after 12 hours? Exactly. I'll set X equal to 12. So Y is equal to 7,500 times 1.3233 to the 12th power. Why the what? Where did it disappear? Okay, because originally it was 4, right? That's what we had. Because that was after 4 hours. Having the number of bacteria after 4 hours allowed us to solve for what the base would be, to allow us to solve for the 1.3233. But maybe I want to know how many cells there are after 5 hours, 6 hours, 7 hours. So I need to make a general equation. I solved for my B, found a general equation. Now I can plug in and find the other ones. So this is how much, like, this is the perfect amount of work for, like, when you have a calculator. This is all the work you need to show me on tests. When I'm like, show your work, right? Because this is a calculator problem. Literally, you plug this into your calculator, 7,500 times 1.322, whatever, to the 12th power, you'll get, 2,000 or 216,000. Oops, I should have picked a color. 216,000 252 bacteria. It is a lot. But like, you see how much work I showed for B? Because it's a calculator problem. Like you just plug it in and it gives you this number. That's it. For me to give you partial credit, you need to show me like the setup. You need to show me how you, like what you entered into your calculator. So it's super easy to make a mistake, push the wrong button, whatever. This is how you at least get partial credit, by showing me the setup. What did you enter in? That allows me to give you partial credit in case you like mistype or anything. Because I hate not giving any credit. So yeah, because that's the answer. That's how many bacteria cells are after 12 hours. And notice I put a unit, bacteria. You're done, wake up. All right. Okay. Just looking at the back of your eyeballs. Back of your eyelids. All right, compound interest formula.
No, I concentrate on this better.
Can you guys read this okay? It's hard to read because it's blurry. So this is the last example we're doing, and then we'll I think we'll actually finish at 3:15 exactly. Yeah.
Are you marking around for CB?
No. Yeah. You were sleeping.
I was not. I can literally retain all the information you just said.
Talk to her after class, bro.
The number of times a year.
Yes, because you were sleeping.
This,
What do you want me to do? You close your eyes for like 5 minutes?
Compounding interest is this, let's say there's like, all it is like $1,000. This is the formula, but if it's like $1,000, you get 5% interest. You get $50. $50. The next year, you get 5% interest on $1,050. That's all it is. So you
Exactly.
get the 50 from the 1,000, and then you get 1% of the $50. Which
You'll
you
get
get 5% of the 50.
which is
And you
$2.50.
just add it together, and then the next year you do the same exact
Yep.
thing.
So now this is compound interest formula. So A equals P times 1 plus R over N to the NT. A is your final amount. It's how much you're ending with. P is your principal. This is how much you're starting with. P, principal. R is your rate, and you need to put this in decimal form. So what I mean is if you have 5%, that means per 100, 5/100ths. Because how many years are a century? 100. How many cents are in a dollar? 100. Like when you say per cent, it's like per centy, per 100. Yeah. Did you know if you have something you can put like per milli is like per 1,000? Not necessary. Okay. Whatever. N, T is the years, T is time in years, N is the number of times per year the bank pays you. So N is the number of times it's compounded per year. All right, so last example, a sum of $8,000 deposited into a bank account that pays 5% interest. Find the balance of the account after 15 years if interest is compounded. We have 3 different situations. I'm actually going to do 4. Semi-annually, monthly, daily, and then continuously. So semi-annually,
6 months.
how many times per year is this? Semi-annually, twice. How many times is monthly? How many times compounded is daily? Right, so that's the number of times per year. You have 365 days per year. Okay, and every single time our sum of $8,000 deposited, so that's my principal, that's how much I'm starting with. 5% interest means my rate is going to be 0.05. Converting percentages to decimals, okay? Find the balance after 15 years. Well, that's my T is 15. So I'm going to be using A equals P times 1 plus R over N, all to the N times T. Okay, so we'll fill it in. A is equal to 8,000 times 1 plus 0.05 divided by 2, all to the 2 times 15. So once again, if you show me the setup, like this is a calculator problem. You have to have your calculator solve this. I don't expect you to do this in your head on paper. This takes too long. No thanks. You just have to have a lot of parentheses.
I'm balling out, I see.
So 16,780 $80.54. So the next one, monthly, it's going to be roughly the same setup. 1 plus 0.05, except this time our n is 12.
Why do we need to add 1?
Because you're adding to it. So not only will you keep the same amount of money you had, like, I can explain in more detail, like where the equation comes from, but I don't want to waste people's time. So you guys only have 6 real problems. Yep. So you gotta be working with your calculator, getting used to it, plug it in. The last one, 8,000 times 1 plus 0.05 divided by 365, all to the 365 times 15.
So you're changing like the n every single.
Yep, I'm changing the n. That's exactly what I'm doing. So I'm gonna try to I'm gonna do more stuff when we go. We'll do more stuff in like the next section or in like 2 sections or something. Because right, so this is like, imagine if I was continuously. So this money is good, right? Honestly, the difference between twice a year and like every single day for 15 years is what, like $200? What if instead of every single day, it's like every single second? No, every single millisecond. Like it's just like constantly, it's continuous.
How much money
Your money doesn't compound like every second.
It does when you have student loans. So when you have a mortgage, student loans, anytime where you owe people money, they love to have continuous interest because it just compounds forever, on and on and on. So this one's a little different because it's roughly the same thing. It's just instead of having 1 plus r over n, you're just gonna do a. It's called a pert. A equals p times e to the rt. We still have like 2 minutes. Hold on.
Wait, so if they say continuously,
That
say no?
it like screws you over.
Is there an option to say no?
No. $16,936. Cool. So that's it for the lesson. It's $16,936. So that's it for the lesson. So when I see you guys tomorrow morning, we will be starting 7.3, which is logarithms and logarithmic functions. So make sure you're on your A game and here on time.